for the first time ever, you're going to see Quantum Portal actually being integrated and showcasing a developer experience of how it is to integrate with the Quantum Portal smart contracts and technology stack itself, and how you can actually conduct testing using the Quantum Portal contracts and infrastructure that is part of the Ferrum mainnet nodes. One of our senior engineers, Luke Moncolia, is actually going to be demonstrating this. So I'm going to go ahead and play that demo now. I hope you enjoy the video, and we'll see you in the next one.
This is going to be a short video on how to integrate with Quantum Portal using the Quantum Portal DevTools. Quantum Portal DevTools is a monorepo. It has two subrepos. The first is the Hard Hat project, which we will be mainly focusing on today. There's also the dev node. Won't be going over this one too much today, or at all really. There is a README in here, which you can go through in your own time. Going back to the Hard Hat project, this is a Hard Hat project, and the first step to start making use of this is to go to your specific project and copy over the contracts folder into inside contracts folder of the DevTools Hard Hat project. I know the naming's slightly confusing. It's contracts slash your set of contracts. In this case, I've already copied it over, I've renamed it to multi-swap. But yeah, of course, we'll rename this as something that makes more sense. So that's the first step. Get your contracts into here, and of course yarn install all your dependencies, keeping in mind that if you have any smart contract related dependencies, you will have to install those. So as an example, I know we make use of Chainlink somewhere. I believe, yeah, it's here. So in this case, you'd have to do your own -d Chainlink, whatever the package name is. So once that's done, finally, once you're inside the Hard Hat project in the DevTools, just run compiler TypeScript, and you're ready to go. So in this particular example, we interact with the bridge through this contract, and there's essentially two steps that need to happen. But actually, before going over that, there's two handy helper contracts, base contracts that you can inherit and make use of. The first is with QP. This is just, setting up the portal, being able to update it, initializing, and so on. And there's the remote peers. This is useful, I believe, probably in most cases where you'd want to restrict which contracts can call which other contracts from source to destination. So in this case, there's a specific contract that you only want to let to be able to interact with your contract from source. This is where you'd make use of this. Of course, you can go ahead and code this logic yourself, but it's here to make use of. So that's just two things to keep in mind. And going on to how to actually do the bridging with Quantum Portal, we have really just two calls to take care of. The first is paying the fee. I'll gloss over this for now and just pass in any dummy amount, but we'll later see how to determine exactly the fee amount that should be passed in. So that's the first step. Pay the fees to the portal target, right, which you can read from the portal contract and what the fee token is. In a live environment, this will be Ferrum, but during testing, of course, it'll be different. And then the second step is not this line. This is not too related to Quantum Portal. It's the actual portal.run call. This will essentially dispatch the transaction through our node system and relay it on the other side. As for exactly what to pass in, the first is the destination chain ID. This is just the chain ID that you would expect. So, Ethereum is 1, Optimism is 10, the base is 8453, and so on. We use the actual chain IDs that these networks use. So that's the first argument. The second argument is the target contract that you want to call. The third is the address where you would want any refunds. This is typically your own wallet address. And finally, the call data. So this is the actual call data that you want to call on the destination chain. In our case, it's finalized cross. So I guess this is a good point to just briefly go over the logic of what this project is doing. There's a user. They could first interact with 5-bit router. This is the entry point, and call cross. Cross just means to do a cross-chain transaction of transferring, in this case, USDC from one wallet to another. So first we take the funds from the user and transfer it to, there's a separate pool which it gets transferred to, and then finally we bridge with Portal. So this is called what we were looking at previously, It's this one, it's this internal function here, and this tells the Ferrum network to relay the transaction on the other side. Once that happens, or rather the way this happens is we finalize the cross by calling this function, and it's exactly what it sounds like. You have a token, you have a recipient, and an amount, and we go and send those tokens on the other side to that recipient. And of course, like in this case, like I mentioned before, most use cases will likely want some trusted source that you would white label yourself, or rather whitelist yourself, and this is just making use of that. One handy thing to make use of is the message sender context from Portal that you get, which will tell you the source chain ID and also the source chain contract, which is calling. In this case, it's source router because it's coming from fiber router. So yeah, this is your source contract, and that's it. This is the call that we want on the other side. So the call data for this is, your ABI encoded, function signature and your 3 arguments, and this is what we're doing here, and this is what we're passing in as the final argument to Portal. And that's pretty much it really for integrating with Quantum Portal. Let's move on to testing. So for that, I already have a unit test script, and actually we'll look at the 3 typical ways of people test contracts. The first is unit testing, so multi-swap Quantum Portal, and the only thing that's really different here is as part of your usual deployment of your project, this is project specific, right? You also deploy the Quantum Portal related contracts, and to do that you just import deploy all from this utils script that we'll provide, and just call deploy all. And the way what this looks like is, you'll get access to this set of addresses. So there's a chain ID, there's the ledger manager, and POC, this is the portal contract, and token is the fee token. So going back to the unit test, so we do this, and as an example, I'm passing in the portal address to my fiber router deployment. So this is how you would access it: context.chain1.poc.address, and for the destination chain side, same thing again, but chain2. And once that's done, you have your deployment logic, and I guess one thing to keep in mind is transfer over the fee token to the signer address, and of course in your unit test, approve for spending to the contract that you'll be calling. And finally, this is the unit test itself. Essentially, we're just testing if the recipient is in fact getting the tokens that we want to transfer. So we record the pre-balance, record the post-balance, and see if they add up to what we expect. And let's try that. H test. And that seems to have worked fine. You can see I'm also console logging the result, so it goes from 0 to 100, and that corresponds with the amount we're passing in. One thing to keep in mind is you will have to call mine and finalize 1 to 2. 1 to 2 just means from chain 1 to chain 2, because that's the direction we're testing. And it takes in 2 arguments. The first is the context object that will be initialized before, and the second is the block nonce. This isn't too relevant in unit testing because each unit test has a fresh state, so it will always be 1, so we can just leave it as that. And just to show you that this is needed, we'll run the test again without doing this call, and you can see it fails because it expected 0 to be 100, but it's not right because we didn't actually transfer the tokens. So, or rather we did, but it didn't get relayed on the other side. So just making sure it works again, and that's fine. One thing to keep in mind, this is using the same in-memory hard hat node, so it's not really cross-chain communication, it's a mock, right? You're just relaying to the same chain. Taking this one step further and testing on 2 separate chains locally, we can also do that. So the way to do that is to first close all of this. We don't need any of this. And let's look at how to first set up the two chains. Let's exit these two and start a local fork. Sorry, not a local fork, just a normal local node on port 8545 and port 8546. I've already set up or configured these two networks, localhost 1 and localhost 2. So that's there. And going back to, let's go to the make file. So this just makes some of the commands easier to do, of course. And this is project specific mostly, but we'll have this example in the repo. And of course, you'll have to modify this to your existing project. So the first step is deployment. So let's do that. Make deploy all local. So that looks like it's worked fine. Let's move on to testing. And the way we'll do that is just using some pre-made scripts that I have. So again, this test is very similar to what we did in the unit test, which is we're trying to send subtokens from one chain to another, from one address to another. So checking the balance of this particular wallet for this particular token. Let's check the balance. So hh run scripts, check balance on the second chain, localhost 2. It should be 0. And let's do a swap. So run scripts, test swap, and of course this will be initiated from chain 1. So we can see that's worked fine. USDC balance before 199 and afterwards 198. So it's left my wallet from one chain. We'll check the balance again. And this is as expected because again we haven't done the mine and finalize step. So the money's left my wallet on chain 1, but that transaction hasn't been relayed on the destination chain. So to do that, we'll need to mine just like before. So it's the same thing as doing this, but between two chains, right? So I believe it's mine QP local. Yeah, and that should have transferred the tokens to my destination chain wallet. And we check again, and it has, the balance has gone up from 0 to 1. So that's working fine as well. So now moving on to live testing. So we'll do live testing between two live chains, so Arbitrum and Base. We'll go from Arbitrum, we'll send some USDC to a destination wallet on Base. So the steps are the same really. We deploy, we do a transfer, and then we check the balance. But in this case, we'll have the benefit of looking at that using a front-end UI like Etherscan. I'm not going to deploy the contracts again because I've already deployed the contracts beforehand to Arbitrum and Base. But instead, what we can look at is the front end. So this is already hooked up to the contracts I've deployed. The thing we're doing is transferring some USDC. So in this case, let's just do 2 cents, and we want to send this 2 cents to an address I've prepared beforehand. This is a fresh wallet. There's nothing here. Let's just refresh this, and you can see this wallet doesn't have anything. So if we put this as the recipient, we have 2 cents that we want to send. Let's do a swap, confirm the swap. It'll take a little while, and there it is. There's a MetaMask pop-up, and we can see that it's taking 2 cents and also 0.392 of the fee token. In practice, this will be the Ferrum tokens, but this has been determined exactly by an SDK, which I will show in the next section, or right after this. Anyway, let's confirm the transaction, and let's see how long this takes to confirm. Okay, yeah, okay, it's already done. And you can see here, this is a test fee token, but this is still in like a live environment, right? This is actual Arbitrum. 2 cents taken from my wallet into a pool that we have on the source side. If we check the destination wallet, of course, it's still not here because, again, like before, we haven't mined the transaction. So essentially, my laptop is being the relayer, right? So If we do the same thing again, mine QP live this time, and of course it will take a little longer because it's waiting for confirmation. We can see it's mined and now it's also finalized. So let's check if the transaction has come through, and we can see that it has 2 cents from the finalized call, and it just happened a few seconds ago. And that's essentially the 3 ways that you would normally test in a typical workflow. So the final thing I want to show is how to use the SDK for fee estimation. In this case, we're using it as part of the front end, and we can take a quick look at how to use that. First step, of course, import the SDK and then define your method call. In this case, as before, we're using finalize cross, which is the function name. These are the types for the input arguments, and these are the values. And then it's just sdk.calculate fee for transaction. The input arguments are what they sound like. So the first is the source chain ID, the second is the destination chain ID, the third is the method call we've defined above here. The fourth is the composing contract or composer contract. This is the contract that's on the source chain calling Quantum Portal. The remote contract is the remote contract where you want to relay the transaction to. And finally, just the beneficiary address. This is just for any gas refunds. That's how you get the Ferrum fee, and this will obviously be the token decimals of the current network, so you can pass this in directly to your contract calls. And that's it. This should be enough to get you started with Quantum Portal.